Hi.
Hi, are you sure this course is just for 2499?
Yes, and you know this is the only course with this expertise across the world.
No way!
Yes way. Don't delay. Enroll now. Hi.
Hi, are you sure you can prepare for product based companies through this course?
Yes, sitting at home?
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
Yes.
Hey, what do you mean by a self paced course?
Well, the course material is available in the form of video lectures. And there are multiple practice problems that come along as well. So, you can access all of it anywhere, anytime. And they are available to you for lifetime.
No way!
Oh, yes way. Don't delay and enroll now.
Geeks learning together.
Hey, hi everyone. Welcome back to this amazing series and which is Learn and Earn series where we are solving the questions from SDE Sheet. Very pleased to see you all here. And this is our day 30. So that's really a very big milestone that we all have achieved. So a very big congratulations to all of you first of all. So hi Adarsh, hi Shubham, hi Shagun. Yes, Nikas, your attendance has been marked. And hi, Sachin. Great, everyone. Very happy to see all these people. You all have been, very consistent throughout the series. Okay, let me quickly first, I will introduce myself. I'm Suniti and I'm a mentor here at Geeks for Geeks. And I will be taking today's session. Quickly in the chat section, can you all please confirm if my voice is clearly audible and also if my screen is clearly visible? I will just share. Yeah. Okay, thanks, Tigers, for confirming. Let's just wait for a few more minutes, all right? So that our fellow friends can join us, and then we shall start our session. Hello, Adarsh. So finally, day 30, right? So what is the maximum streak that you guys are having like this till this far? I'm expecting some of you might have this 30 by 30 streak. Like I have been seeing some of you very consistently throughout the sessions. All right. So you want all the mentors in the session, right? Okay, that's a nice idea. Maybe we can check with the team if that is possible. That's great, Shubham. Great, Sachin. You all have maintained a nice streak. Very happy to see this. Let's just wait for a couple more minutes. Okay. And also, whoever have joined this session, please, just give a quick thumbs up on this video so that we can know that there were this much viewers in our session, and it really motivates us a lot. I'm really very much pleased by the excitement all of you are showing. Great, Adarsh. Great, Meshkat. That's a very amazing streak. All right, let me know in the chat section how this series has been for you all. Okay, maybe we can discuss all that at the end. Let us start with questions. Okay, are we good to start with the questions? Just give me a quick +1 if we are good to go. If everything is good from my side. All right. See, Shubham, we have Yash here with us. Okay, thanks guys for confirming. So let us start our today's session. All right. So this is our first question for the day, and the question is, let me quickly add the banner as well. So the question is common elements. All right. So the question statement reads as, we are given two lists, v1 and v2 of size n and m, and by list here we mean vectors. So we have to return the list of elements which is common to both the list, and we have to return the list in sorted order, right? And duplicates may be there. So what do we mean by duplicates is that if an element is occurring two times in each of the vectors, then in the output as well, they must be occurring two times. Okay. So that is the question statement. Let me now explain with the example. 3, 4, 2, 4. Okay. So we have vector 1 as 3, 4, 2, 2, 4. Okay, just a second. I'm sending the question. Vector 2 as we have vector 2 as 3, 2, 2, 7. 3, 2, 2, 7. Okay. So the question link is, where you go? Okay, guys. So this is the question. We have to find the common elements. Okay, now tell me everyone, what are the common elements in these two vectors? And we need to return the answer in a certain order, which is sorted order. Tell me the common elements. 3 and 2. Okay, but the question statement reads as, if 2 is occurring, if 2 is occurring for 2 times, then in the output as well, they must be 2 times, right? So it will be 2, 2, 3. Okay. So yeah, hi Jatin. Medium level questions have also been discussed. We have discussed questions from all the topics, all right, covering all the algorithms, almost all the data structures as well. So you can refer to the previous videos of this series. So that can help you. And just a second. Okay. So yeah, is the input and output statement clear to you all? Hi Anmol. Okay. Is the input and output clear to you all? Great. So now tell me the first approach, as I can see here, map is there. All right. So how map is going to give us the answer in sorted order? Ordered map. Okay, we can use ordered map. Okay, that is an option that we have. Or maybe we can do the sorting. Sorted map, okay. All right. Okay, guys. So see, what are we going to do is, see, two things matter here. First is frequency, right? And second is the order of elements, because we need to return in the sorted order. So for the frequency of elements, we are going to use map. Cool. And for the order, to maintain the order of the elements, we are going to use the sorting algorithm. All right. So what are we going to do is, okay, first of all, in our map, let me take a new page. We will create a map. Okay, say like map is 3 4. Hello Abhinav. 34427. Okay, so in the map, first of all, we will store the frequency of all the elements, right? So mp3 is 0, mp4 is 2, mp2 is 1, and map at 7 is 1. Okay, and then what are we going to do is 3 3 2 7. Let us say the next array that is given is 7 4 1 2. Okay, so we will apply the sorting algorithm on this array, right? So after applying sorting, what this will be 1 2 4 7. Okay, and then after applying the sorting, we will check that if these elements are already present in the map or not. All right, because if these elements are already present in the map, then what does that mean? That means that all the those are the common elements, right? If elements are already present, it means those are the common elements. So what are the steps here? So the steps is, first of all, create a frequency map, right? Sort the second array, and third, check the presence of elements, the presence in second array. Are these three steps clear to you all? Any confusion in these three steps? Give me a quick +1 if we are good to go to our coding part. Okay, thanks Naikaj for confirming. Sorting the secondary, because we need to return the final answer in a sorted manner. Like all the all the common elements must be returned in a sorted fashion. That's why. Problem link I have shared in the chat section itself. It will be updated in the description as well. By tomorrow it will be done. All right, everyone. So that's a thumbs up from all of you. So yeah. Okay, so yeah, as this is our last session, so I hope, in all the sessions, of course, you all have helped me throughout the coding, but in this as well, I want help from you all. So yeah, tell me how shall I start doing this question? Okay, let me create the map first of all, and then maybe we can start with the algorithm. Okay. Now tell me, what is the first step that I need to do? Frequency hash array, create map, and insert elements in map. Cool. Let us do that. So current is equal to 0, even dot size. All right, I have done that. Now, great Anmol, Naikaj, Meshkat, that's the right answer. Now, what is the next step that I should do? This step is done. Sort V2. Great, Meshkat. It means you were very attentive. Okay, done. Great, Anmol. That's the right answer. Now, what we shall be doing now? Sort V2 is done. What's next? We have created an ordered map. We have inserted elements. We have sorted the second array. Now what we shall do to add the elements? Check elements in map. Decrement map values according to V2. Okay, so shall we start iterating over V2, right? Yes, great, Ritik. That's the correct approach. Second array has been sorted. So now let us start our traversal. And V2 dot size and I plus plus. Okay. So shall I now check the presence? If MP at V2 of I is greater than 0, let's dot push back V2 at I. Okay. And I will be returning this. But there is one thing that I have missed here. What is that thing? This code is not going to give the correct output because one step I have missed. So what is that step? I just want to know if, let us see who figures it out the first. Okay, great, Anmol. We need to decrement the frequency. Great, Meshkat. So which line needs the editing? In which line shall I do this? Like that sorting has been done in line number 20. Great, Adarsh. We are going to decrement the values. But can anyone help me with the line number? Where shall I do this? Inside for loop. Okay. After if. Correct. So if MP of V2I is coming greater than 0, then first of all we will decrement the frequency and then we will just push back. Great, Naikaj, Adarsh, Anmol, all of you are correct. Let us now see if it works. Yeah. So submit. Great, we have solved the problem. So yeah, let me just do this. Okay, so just see the coding section. If any doubt, any confusions, please do ask. Or if not, then give a +1 so that we can move to our next question. Great. Thanks everyone for confirming. Great. Okay, so no confusion. All right. Let us now move to our next question, which is, and now I remember I need to change the banners. And also I need to share the question link. Thanks, Adarsh. All right, guys, so that is the question link. And yeah, so the question is search in a rotated array. Okay, now tell me, this is search in a rotated sorted array. So you guys tell me, what algorithm do we use when we are searching in a sorted array? What was that algorithm to search in a sorted array? Okay, along with the time complexity. Okay, why binary search is having the time complexity of log n? Yes, there are plenty of correct answers. Jatin, Shubham, Satyendra, Ritik, Gaurav. We have plenty of correct answers here. So why the time complexity is log n? It's monotonic function. Okay. So why log n? Because maybe every time the search space is getting reduced, exactly, Anmol, that's the right answer. Every time the array is getting divided into two parts, rather it is getting halved, right? Like our search space, we are like halving it in every iteration. Exactly, in each iteration, array is halved. Great. Okay, so we are clear on that part. So yeah, the question is we have to now search in a rotated sorted array. Okay. So the question statement is we are given a sorted and rotated array A of n distinct elements and which is rotated at some point and a key is given to us. Cool. And the task is to find the index of the given element key in the array A. All right. Do you think we really need to find the pivot? Maybe we can do it without that. Let us see. Okay, so this is 5, 6, 7, 8, 9, 10. 1, 2, 3. Let me start. See, the array given is 5, 6, 7, 8, 9, 10. 1, 2, 3. Okay, tell me in the comment section how many of you are thinking that we can use binary search here as well. Algorithms similar to binary search can be used here. Modified binary search. Exactly. Nikes, that's correct. Okay, Tarun, by pivot, if you mean the mid element, then yes, you are correct. Meshkat, yes. Okay, so we are going to use a binary search here, all right? So, great. Now, tell me if this is an array that we have, and yeah, how many elements are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 elements here. So when we will index from 0 to 8, so it will first iteration we will get our mid as 8 divided by 2, which is the fourth element. So 0, 1, 2, 3, 4 is here. Now tell me one thing. If this part is not sorted, right, then is it necessary that this part will be sorted? Or if this part would not have been sorted, then can we conclude that this part will definitely be sorted? Like, see, if we are having a rotated sorted array, right? Array is sorted. So let us say if this is the midpoint, okay? So let us say if this portion is not sorted, then we can conclude that definitely this portion will be sorted, okay? Exactly, we can do that. So see, what are we going to do is, first of all, we will find the mid element, right? Similar to what we do in binary search. Great. Now, if this mid element is coming equal to the target, right, then we are going to return this mid element as we do in the binary search. Now, the difference here is, see, if this is our starting point, say this is L, and this is our ending point, this is H. Now tell me, if element at L is less than element at mid, does that mean that this part is sorted? Yes, exactly, Anmol. Half of it will always be sorted. So help me with this. if array at L is less than array at mid, okay, then we can imply that first half is sorted. First half sorted. Okay. Now, first half is sorted. We are clear on that part. So now we will check that if our target lies in this range or not. All right. We will check for our presence of the target in this range. Okay. This part is sorted. We will check for the presence of our target. Okay. Like the array was initially in an increasing order and then it was rotated. Okay, so now we know that array at L is smaller than the array at mid. So now we know that this part is sorted. Now we will check that if our target lies in this part or not. Okay, yeah, we are doing that part. This is the first condition. Okay, we are on the first condition when array at L is less than array at mid, and then we will check that if target lies in this range. All right, if our target is greater than L and if our target is greater less than mid. Okay, so in that case we can do this, that we will move toward we will do our ending as mid minus 1 if our target is, see, this is the array. Okay, and if target is greater than the lowest and target is less than the mid. Okay, see, here is L and here is M. Right, now we are sure that our target is greater than L and our target is less than mid. Then can we move our ending as mid minus 1? Because here target is less than mid. So suppose initially our H is here. Okay, so now can we say that our we can reduce our search space to this point? We don't need to search here. Can this conclusion be drawn? Is this conclusion clear to you all? All right. Thanks, Shagun. Thanks, Meshkat, for confirming. Okay, so what I'm saying is that if our target is greater than L, okay, this is the first condition. If our target is less than mid, okay, uh, and also the condition was the array at low was less than the array at mid. This was also condition, and this is the sub condition for it. Okay, so yeah, if the target is greater than L, if the target is less than mid, okay, and here it will be greater than is equal to, here it will be only less than. Why less than? Because equal to condition we already compared in the previous line when we are checking that if num set mid is equal to target. All right, in that line that comparison has done. So now if target is greater than is equal to L and if target is less than mid, then in that case we don't need to search in this much space, right? This much space is of no use to us. Of course our space will be this much. So that's why we will reduce our H to mid minus 1. Else, if this is not the case, then we will increase our lower point to mid plus 1, right? Because if our target is not lying in this range, it means target is lying in this range. Okay, and what will be this range? Like we need to now start L from mid plus 1. Cool, which is mid, this point, like mid plus 1. So are these two steps clear, if and else? Just give me a quick plus 1 if it is clear to you all. Okay, how we are reducing the search space? All right, so our main motive was to reduce the search space. So this we have done here. Now here we have considered that array at L is less than array at mid. Now let us say if that is not the case. Okay, if array at L is not less than array at mid, say it is 9 8, sorry, Yeah. So let us say the array is 1, 2, 3, 4, 5, 6, 7, 10, 11. Now in this case, suppose mid will lie somewhere here. Let us say mid element is this one. Okay. Now tell me, in this case, is array at L less than array at mid? In the previous case, array at L was less than array at mid, so our search space was shifted accordingly, right? Now tell me, in this question, is that the case? Is array at no? Okay, let us see if everyone is able to see this. Okay, in this it is not the case. Okay, so what are we going to do here? It becomes our else condition. So if array of L is not less than array of M, does that mean that this second part is sorted? Can we conclude this? Because L was here, M is here, and H is here. So can we conclude this? Yes, we can conclude. See, if array of L is not less than array of M, it means that this part is not sorted. And if this part is not sorted, it means that this part is sorted. Cool? So now what we are going to do is, again, we will do the same thing. We will check that if target is greater than numset mid, all right, and if target is less than is equal to numset h, then in that case tell me which pointer shall we move. It means target is lying in this range, so which pointer shall I be moving? If target is greater than numset mid and target is less than numset h, L is equal to mid plus 1. Very great. So we will start L from mid plus 1 because this is our required search space. Exactly. I am very happy to see the correct answers. And in else condition, we will move our H to mid minus 1. Because if target is not here, it means the target is here. Okay. And what is this point? This point is mid minus 1. Cool. Now give me a quick plus 1 if this logic part is clear and we are good to go to our coding part. Thanks, Shishir. So yes, everyone. All right. I see no any confusions here. So maybe with our coding. Thanks, everyone. So let us see how we are going to code this. Okay. So I'm going to start with my while loop. We will find the mid element, which is L plus H minus L. No, we don't need to sort the unsorted part. Sorting is not required to be done at any condition. So, because see the array is already sorted, all right. So when you are reducing the search space, then at some point you will definitely reach a search space where all the elements are sorted, right? Either left half of the array will be sorted or either the right half. So either half will always be sorted. So you will never need to sort the unsorted part. A of mid is equal to key. Then we are going to return what index? We will simply return mid. Now, if A at L is less than is equal to A at mid, right? Then what are we going to do is we will first check that if our target lies in this range or not. Now tell me the code to check. How can I check if my target is in this range? What shall I write here to check the presence of target in this range? target greater than A of L? Great, Meshka, that's the right answer. But A at L can itself be the target. So maybe just we can add an equal to sign there, okay? Target is greater than is equal to A at L, and then target is less than A at mid, okay? We don't need an is equal to sign in this A of mid because we have already checked for that condition. If this is so, then we will do our high as mid minus 1, else we will do our low as mid plus 1. Cool. Okay, Aman, in if condition, we are checking, see if array of L is less than array of mid, then it means that the first part of the array is sorted. So we are checking for that part, that whether it is sorted or not. And if it is sorted, then we are checking that whether our target lies in that part or not. All right. So that we have done. Else, if the first part is not sorted, then we will check for the presence of target in the second part. That is, if target is greater than A of mid and target is less than is equal to A of H, if this is so, then our L will be mid plus 1, and else our H will be mid minus 1. All right. And even if we haven't found our element after doing all the procedure, then we are going to return minus 1. Okay, so I guess the code is good to go. Let's check. Okay. Target. Okay, it is key. So maybe we can change the name here. And here as well. Great. All right, guys. So this is the code. Yeah. So now let me know if any confusion, any queries in this code. It will be resolved. If we have any problems here. Okay. And also, I want each one of you who is viewing this series right now, please give a thumbs up on this video. Like, that would be really nice of you all. Everyone who's watching this video, just make sure that you have given a thumbs up for this. Like, you have liked this video. The number of viewers should be equal to the number of likes that we have on this video. Yes, thanks, Parambrata. Thanks, Shubham. Yeah, okay, I'm last problem. All right, we are going to move there as well. Okay, all right, guys. So we are good to start. Go to our next or the last problem. So okay. So the question is, now I remember I just need to change the banners and I need to provide the link. Okay, where is the link? What just happened? Just give me a second. Where it is? and in the comment section. All right, guys. So, like, this is the last video of this sheet, but we just got an update from the team that this is not the last stream, right? We are going to do such sessions again. We are going to bring some new series, some new streams that we will be doing. So, yeah, this is not the last series that we have here. Stay updated with us. We will bring something more exciting and more interesting, and of course, with some much challenging questions. All right, so our team has just updated us. So yeah, just keep in touch with us. We will bring such exciting challenges for you. Okay. So yeah, let us start with our question. So it is array pair sum divisibility problem. All right, so we are given an array of integers and a number k. We need to write a function that returns true if given array can be divided into pairs such that sum of every pair is divisible by k. Okay. You're most welcome, Shishir, Shubham. Very happy to see the support, the excitement you all have for these series. And we are equally excited as well to, bring up such sessions. So, yeah, learning is always fun, and learning in such an interesting way is really fun. Okay, so let us now focus on the question. The question says that we need to divide our entire array into pairs such that a sum of the every pair is divisible by an integer k. Cool? All right. Actually, this question I kind of find tricky a little bit because the logic that is used in this question is really interesting. So that's why this question. Okay. So 9573 k is equal to 6. See, here we have 9, 5, 7, 3, and we have k is equal to 6. See, the first condition is if array dot size is odd, we will return false without checking anything because we need to divide in pairs. Is this concept clear? If array of size is coming as odd, then we will return false because we need to divide the array in pairs. Right. Okay. Now second thing. Here what I'm doing is, tell me how can we divide this array so that it is divisible by 6, 9. Okay, 9 plus 3 is 12. Okay, so 9 and 3 is 12 and 5 and 7 is 12. Okay, so 9 plus 3 is equal to 12. 7 plus 5 is equal to 12. Cool. So as we saw that we have divided this array in pairs and the sum of the each pair is divisible by 6. Okay, let me now take another example. Okay, now you guys tell me, suppose we have two elements 56 and 24 and we need to check if it is divisible by 10 if there's sum. So is 56, yeah, brute force approach, that is correct. We will make every pair, but yeah, but maybe that will take quite a long time. Like you'll have to check for every pair, then the pair that you have already used, you'll have to remove it. So yeah, maybe that will be very tiring. But yeah, as the name suggests, it is brute force, so it is meant to be like that. Okay, is the sum divisible by k? Sum of 56 plus 24? Yes, exactly. That's why it's a brute force. So now tell me, is the sum divisible by k? (56 plus 24). Of course, it is divisible. 80 is obviously divisible by 10. Now, let us observe some pattern. What is the remainder when 56 is divided by 10? Remainder when 56 is divided by 10? 6. And the remainder when 24 is divided by 10? 4. And what is 6 plus 4? Exactly. So what we concluded here is, if sum of remainders modulo k, exactly, I mean if sum of remainder modulo not, if sum of remainder is equal to k, then it means that a pair is formed, a valid pair is formed. Right? Is this concept clear? Like let us say if there is a number which is giving a remainder rem, then the remainder given by other number should be k minus rem. All right. So if such numbers exist, then they will make a valid pair. Is this logic clear? Give me a quick +1 if this thing. Cool. We just saw why. That if a number is giving a remainder rem, for example 56 was giving remainder 6, and if another number is giving a remainder k minus rem, for example 24 was giving remainder 4, then it will make a valid pair. Right? 56 plus 24 makes a valid pair. So this is the first point, and also second thing. Okay, all right, tell me, does 20, exactly, we will first find remainder and then we will check that if we have such pairs or not. Okay, if we have such pairs, then it means that we can divide it in a valid pair. Okay, now tell me, 20 and 30, will they sum up to give a number which is exactly divisible by 10? Twenty plus 30, is it going to give us a number which is divisible by 10? Exactly. So what is the remainder when divided by 20? 0. Remainder when divided by 30? 0. So it means that if there is any number which is giving a remainder 0, then corresponding to it, there must be a number which is giving a remainder 0, which means that frequency of 0, frequency of numbers giving remainder 0 should be an even number. Okay. Is this logic clear? We will make a frequency map to store all the remainders of all the elements. So the number of times we are getting the remainder 0, right? That must be an even number. Is this logic clear? Yes. Okay. Great. Because see, uh, if you have elements as say 20, 30, and say 56, 40. So see, these two numbers will get paired up, right? But this number was also giving a remainder 0, but there is no any number to which we can pair this element, right? So it means that we can't divide this array into the required condition, right? So see, like how a frequency of 0 remainder will be what? 3. We are getting remainder 0 from 3 elements, 20, 30, 40. And as 3 modulo 2 is not is equal to 0, which means that divisibility is not, the array dividing into pairs is not possible. Okay, we can't make the pairs out of the given array. Is this condition clear? Great. So that was all about the logic part. Like, two things we need to check. First, what we are going to do is frequency map of remainders. Now, frequency of 0 modulo 2 should always be equal to 0, and for every frequency of remainder, there should be a frequency of k minus remainder. All right. So for example, say frequency remainder is 6. Okay. Then there should be an existence of 4. All right. Only then the array can be divided into pairs. If 6 is existing, then 4 must exist. If 3 is existing, then 7 must exist. Exactly. Great, Meshka. Thanks for concluding it. Like you have written it in a very nice manner. All right. If 8 is there, then 2 must be there. Remainder. Cool. Are these 3 steps clear to you all? Give me a quick +1 so that we can move to our coding part. Alright, give me a quick +1 if we are good to start. Okay, thanks Meshka, thanks Naikaj, thanks Sharad. Let us start. Okay, so we are going to use a map here. So we will create an unordered map. Simply at n modulo k plus plus. Now we will again start the iteration in our array and we will check for the conditions. Okay, so what will be the remainder? Say current remainder is num set I modulo k. So we will check that if this remainder is coming to be 0, then what was the condition that we need to check? Yes, exactly. A little bit of math is being applied here. What is the condition that we are checking if remainder is 0? What should be the frequency? That should be even. And if it is not even, then we are returning false. Is this clear? Because we need the frequency of 0. Yeah, that should be even. Exactly. Frequency of 0, if it is not even, then we are returning false. Is this clear to you all? And else if frequency at remainder, whatever is the frequency of this remainder, that should be equal to the frequency of k minus remainder. And if it is not so, then we are also going to return false. Okay. And if there is not any false from these two conditions, that it means that the array can be divided. So let me know if any confusions. First of all, let me check. Frequency was not declared. Okay. Okay, that's the wrong answer. Maybe did some mistake. If remainder is 0 and okay, so we have for int I0, I is less than num dot size I plus plus. We are storing remainder as thanks. If remainder is 0, frequency of 0, modulo 2 is not 0, we will return false. Else if frequency of remainder is not is equal to frequency of k minus remainder, then we will return false. Maybe we have missed any condition. Alright guys, just give me a moment. Let me figure out what is the issue here. uh, remainder is set I modulo k. Is there anything that you all can see which is wrong? If remainder is 0 and if frequency of 0 modulo 2 is not 0, should we add a bracket here or what? I don't think so. Maybe we can remove this condition. Okay, that's again a wrong answer. Alright guys, just give me a moment. I just need to check what is the issue here. Set I. Okay. Alright guys, so tell me what is the issue that you all guys can see here? Anything that I missed out? Just stop sharing a lot. Yes, thanks Anmol. Yeah, this was the question. And this is our submission which is not getting. Okay. So if remainder is 0, then we are checking that if frequency is not 0, then we will return false. And else if frequency of remainder is not is equal to frequency of k minus remainder, then in that case as well, we are going to return false. So look, the logic needs to be correct. Rest, this small errors is private. All right, maybe I just erased the scope. I think all the checking part has been done. Like we just need to check that the this 0 should be in pair. And all right, we just need to check two things, that this 0 should be in pair, like it should be an even number. All the numbers that are giving remainder 0, they should be in even. And if there is a number whose remainder is rem, say, then there must exist a number whose remainder is equal to k minus rem, right? Like these three conditions we are checking. So are these things clear to you all? Is this code clear to you all specifically? So that was the question that we had. Just two conditions we are checking, that 0 should be in pair, like it should be in even, and frequency of remainder should be equal to frequency of k minus remainder. All right guys, if any queries for any of the questions, do let me know. Okay, this was not an instant logic. Actually, I have practiced this problem before as well. The first thing, while I was solving this question for the first time, so that time I had this thing clear in my mind, like after checking for some of the pairs which are making valid pairs, then I had these two things in my mind, that the conditions that we need to check is that remainder 0 should be in pair and frequency of remainder should be equal to frequency of k minus remainder. So that was there in my mind. This use of unordered map, that for that I had to look for hints. So that was there when I have solved this question for the first time. So now with practice, I know how to solve this instantly. Course coupon, regarding this, all the information will be given to you through the proper channel. Just stay connected with us. We will give you all the proper details that are required. Yes, Nikaj, I have done this problem by my own. And I mean, that's how we practice questions, right? That's the only way of practicing the questions. Now, let us quickly discuss the time complexity and space complexity of all the questions. So, yeah, what is the time complexity and space complexity for this question? Let's first start. This was the first question of the day. And log n. Why? Because we have used sorting here, okay? And space complexity, space complexity will be linear space, exactly, Satyendra. That's right answer. Now for this question, what is the time and space complexity? Time log n, exactly, and space constant. Great, Nikaj. And for this problem, n and n. Okay, are we all right? We are doing a linear traversal. Okay, everyone. So that was all about today's session. And the SD sheet link has been shared in the chat. Okay, that has been pinned as well. So try to solve all the questions from the SD sheet. And if there is any problem, if anything, any query that you come across, feel free to ask in the channel. The mentors are always there to help you all. So yeah, that was all about the today's session. Any feedbacks, anything from your side? And also we will be meeting again with more such interesting series. So if there is anything from your side, do let us know in the chat section. And any feedbacks for this session, any suggestions for this session, any improvements, everything is welcomed. It was really very nice interacting with you all, and I was pretty much happy to see the enthusiasm that you guys were having. So you guys are accessing this sheet, right? So make sure. Yes, I am also looking forward. Thanks, Neha. Very happy to see that these sessions were helpful to you. Coming session time, we will keep you updated. Just stay in touch with us. Thanks, Shagun, for such a beautiful compliment. Okay, so this is the link of the sheet. Solve the questions from that sheet. All right, that will be very much helpful. And keep up doing the hard work that you guys are already doing. And yeah, solve as many questions as you can. Practice consistently. Be consistent, right? Do the hard work. So, all right, guys, that's all about today's session. Thanks for attending it, and we will come back soon with more such interesting sessions. Stay in touch with us, stay updated with us, follow Geeks for Geeks, right? And keep on solving the questions. Good night.